Hello and welcome to this introductory session on Creator. Today, we'll be introducing you to the concepts of MBT. We'll be walking through the high-level architecture of Creator, and we'll be deep diving into the Creator's functionality and behavior. Talking about MBT, MBT stands for model-based testing. It's a concept where the application under test or the system under test is modeled, whether the application exists in production and we are doing the changes, or the application is being built brand new and only the specifications are available. The application can be modeled for its behavior, and that model can be used for generating the test cases. Okay, now let's look at the high-level architecture of Create. So as you can see from your left, we can import the requirements from upstream requirement management system. We can import the business assets like BPMN files, the PIN files, and Visio flowcharts. We can use test assets as well, manual test cases from Excel sheets or HPQC, or automation scripts assets like UFT scripts, UFT OR, or Toastfile modules, and even the API definitions like SOAP and REST. So based on the assets that we have in hand, we can use these assets in jumpstarting the model creation. But irrespective of that, the creator provides a UI for adding new models or updating existing information of the models. Once the models are available and reviewed, we have controls across the model for the user to define what kind of test cases he wants and what coverage he wants. Once the settings are all set, the clicking of the button generates the test cases. These test cases can be exported for manual test cases like Excel-based files, or tool-based export like HPQC or Jira Zephyr. This can also be exported into automated scripts, which can be used for executing automatically. So these scripts are available into various frameworks, whether it is the default market level Selenium Java, Selenium based Robo framework, UFT, or it can even be in-house frameworks. We back ourselves to integrate with the framework you have. So all this while we have integration with test data, we can manage the test data, we can manage the requirements, and these all end-to-end processes are managed via the CI/CD pipeline. We have AI built into many of the steps that we haven't talked about. So you can imagine the amount of AI to read different types of files to jumpstart the model creation. We also apply NLP, natural language processing rules, to read the manual test cases and the ducking files. Intelligence is also built inside the tool while modeling, so that errors are shown and user is guided to do the right way of modeling to avoid coverage issues. The most important during the test case generation, the data and path are applied together, and the most optimal suite of test cases is generated for the given coverage. There is another powerful set of API libraries which we use to generate the automation scripts in any language. As you have already heard, we can generate for Selenium Java, Selenium Python. For Robo framework, we have UFT, and for any custom tweaking based on the frameworks that you have. So we have the data, we have the locators, we can handle the locators, and we generate the executable piece of code. So we can do scriptless automation with creators output. We can take the output, put it in the execution framework, and just hit run button. We can also say these scripts are first generation of self-healing because we handle more than one locators. If the first locator fails, we can pick up the second locator to try and execute and pass that script. Of course, these updates, the updated locators need to be fed back into the model to keep the model as a source of truth. So in this case, let's look at a particular application. So this is a very simple web application. This is all the GUI related information. You have URLs, you have text fields, you have buttons, and these are all the GUI fields, the graphical user interface. The second piece of information that we generally need is the sequence of steps. Now, in this case, I can type in the username, I can type in the password, and click login button. Once the user clicks and the operation is successful, logs in here, this is one set of sequence of steps. If the user gives the invalid password or doesn't give the password and clicks the login button, it's an error. So these are two different sequences of steps. We call this two different flows. Now, how this information of the application is used to model, that's entirely up to the application itself, the tool itself. In this case, we'll be talking about creator on the MBT space. So this ends the high-level architecture overview. Let's deep dive into the demonstration of a walkthrough itself. So let's deep dive into the tool workings. So this is a tool that you can see on my screen. So this is Eclipse based. You can see different perspectives: ConformIQ modeling, ConformIQ test design, ConformIQ test review, and then there are other views based on this the functionalities that are required. Let me create a new project for the demonstration purposes. So basically, two pieces of information we saw at the starting of this demonstration. One is the GUI level information, and the other is the sequence of steps tied together. So we have a type of file called structure diagram, as the name indicates. So this is a file that holds all the GUI related information. As you can see, as in when I create the file, the top menu has changed. This is contextual menu for giving the options to the user to define the screen structures. So I can have a screen, let me call it welcome screen. Then I can have a form. Form is all the data entry fields clubbed together. So let me call the credentials form. It had two fields on the UI. One is username and the other was password. And then there were some links and buttons. So let me call this login button. And then there was a link for forgot login info. So I can continue creating all the screens of the application like this. At this moment, I'll just stop here. The next step is to write the activity diagram, the flow chart. So basically, the rules of the flow chart apply. I have a start node. I have one activity wherein I'll just call welcome, and then I just need to drag and drop. So I have this fill credentials form, click login button, and then I just need to connect all those elements together. I can continue this creation, and if that looks, if I complete that, this is how it will look. So I have here register screen, forgot our info screen, administration screen, different types of widgets. These are radio buttons, drop downs, and so on and so forth. So if I look at the complete activity diagram, so this is how my activity diagram will look. So this is, I'm launching the browser. I have the login. I can either enter the credentials or click the admin link or click the forgot login info link or click the register link. And if I'm clicking, entering the details, clicking login button, then the details are validated. And if my login is successful, I can perform various actions like request loan, accounts overview, bill pay. So this is the high level overview of what an activity diagram looks like. We can integrate the requirements as we spoke before. So this is how to integrate the requirements. So these are the existing integrations. We can pull the requirements from Qmetry or Jira or HPQC. At this moment, I have from Jira and ad hoc requirements and Excel requirements. So these requirements can be mapped to the flows, to the sequence or set of actions. Now, if I'm interested in verifying the login success, I just need to map it to the login flow, login box. And if I'm looking at administration, I can map it to the administration. It's just a matter of drag and drop. Once the requirements are mapped and the activity diagram is saved, you can see this tick mark, which says in model. So which means requirement has been modeled. Any changes of the requirements in the upstream system, we can pull those changes with this icon, update requirements. So any new requirements will be highlighted in green. Any updates will be highlighted in yellow, and any deleted requirements will be highlighted in red. So the appropriate changes can be made into the model, and then the changes can be acknowledged. There are other ways to create the model. We spoke about imports, importing from existing assets. So these are all the assets that we can read and import. Basically, we can read any structured file like an XML or a JSON. We just need to understand the structure as per the setup or definition of the JSON file. Yeah, as you can see, we can BPMN flows, Visio flows, or automation assets like Selenium assets, QTP, or web service based files like RAML files, and WADL files and WSDL files. So based on all the information that are available, that we can read. We can capture information and create the models, maybe just the GUI information or maybe even the activity diagram, the sequence of steps. In this import, I would like to highlight the new import that we have added in the recent past. This is called web page scan. So this is once you launch this import and you select the project where you want to create the or import the assets, you have to provide a URL. The URL will be launched by the tool and you can capture all the contents of the screen, all the widgets and their individual locator values, one or more locator values as per your requirement. We can capture, and at the click of a button, all the elements are converted into a structure diagram. This is a screen that I have captured using that tool. So in this case, as you can see, this form, this screen, this form, and these fields have multiple locators, its path and as well as the name locator. So the next obvious step is to generate the test cases. So first is the load model button. Once I click load model, the middle pane here gets updated for any changes. So this middle pane is the test targets view. This has every element of all the activity diagrams. Right now we are only seeing one activity diagram here, but this is a reusable function kind of. So we have put it under a sub-activity diagram. So all the main activity diagrams elements plus the sub-activity diagrams elements, the boxes, we call it activity nodes, the actions itself, the data elements, as you can see here, the decision boxes, the branches, everything is a target for the tool to cover, including the requirements. The next step is the generate test cases button. When I click the button, a process is starting at the bottom right, and we can see the progress panel messages. We can see the coverage. Okay, the test case is generated, and at the bottom right, you can see all the test cases available. As I have indicated before, so this list of test cases is the most optimal in the sense that both data optimization techniques and path optimization techniques have been applied, and the least number of test cases have been generated for the given coverage. So the middle pane now gets updated with the coverage, whether the requirement, whether the element in this tree has been covered or not. The green tick mark indicates it is covered, and at the top you can see 100%, the numerator and the denominator. So these are the scripters. So this is where we have lots of integration. These are the core product based descriptors available with the core product itself. So we have Excel scripter for manual test cases in Excel format. We can export the test cases to Jira Zephyr, QCLM, QMetry, QTest for manual test case management. We can also export the test cases into automation scripts, whether it is file-based or tool-based. So as you can see, we have QTP UFT or UFT VB scripter or Robo Framework or Selenium Java or even Tosca. So let's take a couple of scripters as examples, Excel scripter and Selenium Java, and let's try to export the test cases. You don't see any folder called test cases, so let me just click export and see what happens. Okay, it's done. So let's open this folder. So we have this Excel test suite. We open that. So this is the default file format. So you can see this is the dashboard when it is generated and what are the settings and then the coverage. The next tab shows you all the test cases that have been generated. 25 test cases. Basically the format is left hand side is test steps, right hand side are verification points. This template can be modified if the Excel file itself is of interest to you. This is the traceability matrix. So we have all the test cases listed. We have all the targets, including the requirements as a section or activity diagrams, nodes, data elements. Everything is a target as we have seen inside the tool. And then we see the traceability matrix, which are the targets every test case covers. Because we have the requirements, because we have the test cases and this mapping information inside our tool, we can also export this information and create a map in the test case management tool, like in Jira Zephyr or QTest. So we can export the test cases into Jira Zephyr and map it to the Jira user stories. So you have the traceability matrix available inside the tool, and you can use that information for any analytics. Talking about the automation, all the structure diagrams information are under the page objects. So for example, if I open this one welcome page that we have seen, so this is the username field and the different verifications that can be applied, whether it is enabled or visible. And this is the code for interacting with that field. We identify the element types and we generate executable code for interacting with that element. You can also see the XPaths, the locators that we have seen within the model. So whatever data creator holds, it is also exported into the format that you want. So this is a test case ID 1 and we have mat for the username and valid password. So coming back to the creator, let's have a quick look at the other folders. So these are the test suites. If I'm taking any administration, every Java file is one test case that the creator has generated. So we have just listed out all the steps of the test case. So that's the test suite folder and the utilities folder, which is Excel reader and other configurations which are basically required for the framework to run properly. We also have this parallel or sequential runner files and the GUI and the NLP files for configuration purposes. So this is whatever has been generated. You can take this SRC folder, put into the execution platform and just click the run button. So it should execute. So we should also be able to loop this. If the first one fails, we should be able to provide the second one within the scripts. So that is the first generation self-healing we are talking about. I would like to introduce one last concept, which is basically an extension of all the modeling and test generation verification aspects that we saw, but the modeling itself is in a different way. So this is a different way of modeling. Here, if you see, we have these business actions with given, when, then. We are in the process of adding more Gherkin compatible keywords. So if you have the requirements in feature file or your team follows Gherkin BDD approach, so the modeling is still possible. The structure of MBT as a layer on top of BDD helps you model it right. And the tool as an extension of MBT concept unique to this tool, unique to us, generates the optimal number of test cases for both path and data. We can also generate the step definitions, the templates, whatever information we can hold. GUI level information for this BDD models. We can capture that, associate that with the step definitions and generate page object models output for you so that the model becomes again the source of truth. Any questions, please reach out to us at support@conformiq.com. Thank you for watching.